question is asking us how far did this fragment of a shell fall from its original position. Now I split it up into two parts. One where this is x1, the distance before, right before it explodes at point A, and we're just gonna call this point A to make it easier. And then x2, the distance this fragment has traveled. Now to find the total time, which I used to get these distances later, I used the second kinematic equation, and I got time here. Now to find x1, you use the velocity in the x direction from the initial velocity, and you use half of the time because ta, the time it takes to travel x1, this distance right here, this is the distance the shell has traveled, which is half of the full experiment, of the full shot. So x1 is equal to 17.65 meters. Now to get the distance of x2, we use conservation of momentum. So like the momentum initially has to equal the momentum final. So we have m vox, because at point A the velocity is vox. That's the initial momentum, and then we have the mass of this little triangle thing times the final velocity, and we're looking for the final velocity, so we could do the same thing we did for x1. Now we cancel all m's and we get the final velocity equal to 20, and now we do the same thing as we did for x1. We multiply 20 times half of the time, which is the time it takes to get to part A, and that is the same time throughout, and we get 35.3 meters. Now I didn't put meters, well that's just going to kill me. And we add the x1 plus x2 to get the displacement, and that ends up being 52.95 meters. Okay.